Okay, example 3. I'm going to skip that one problem. It's the same. We're going to do 3 more plus the applications. So we're going to have plenty of actual practice. Now, use the law of sine to solve the triangle. Anytime they say solve the triangle, they want one. But here, they're asking specifically. So if I ever ask for that on the test, you're looking for the 2 cases. You're looking if it is possible to have the 2 cases. What you do, again, a rough graph. A is 115 degrees. So 115 degrees is a bit bigger than 90. So maybe something like this. Maybe. Again, I don't mind you drawing this any way you like. And since the other problem looked just like that, because there's 101 degrees, I'm going to go for that as well. So first things first. If I label this angle as 115 degrees, then that's 25. B could be anywhere. Let's say this is angle B, so that makes this 17, C, and there it is. I'm going to have to start with the sine of 115 degrees divided by the opposite side, and the only thing I could find at this point is B. Beta, I'm sorry. So doesn't that mean that the sine of beta equals 17 the sine of 115 degrees divided by 25, which is, if I take 17 times the sine of 115 and I divide that by 25, I'll get that to be 0.616. I'm using answer on my calculator, so it doesn't matter. And if you round, that's not a big deal, but be careful. So in this case, since I'm finding beta, beta is one of 2 angles for me all the time. Anytime you find beta, you're either in quadrant 1 or you're in quadrant 2. You never know, because sine is positive in both of these quadrants. If I take the inverse sine of my answer, I will get either 38.05 degrees, that's here, oops, that's here. And if this is 38.5 degrees, then this is 180 minus, and that would be 141.95 degrees. Well, let's see. Since I know this angle is already 115, right? There's no way another angle could be bigger than 90, because those two will add up to more than 180. So in this case, it's safe to say this is simply 38.05 degrees. And once I have that, pretty much I got everything else down. I know how to find this angle. That's 180 minus 38.05 minus 115. And that turns out to be 26.95 degrees. And the sine of 115 to 25 should equal the sine of 26.95 degrees to angle C, side C, and C will equal a bit more space. C will equal 25 the sine of 26.95 degrees divided by the sine of 115 degrees, and that would be 12.5. Now, if I really look at the sides, they should make sense. The smallest side should be opposite of the smallest angle, and the biggest side should be opposite of the biggest angle. And that makes sense. Now, when I get to example D, luckily, that problem doesn't require a lot of space. I can seem to catch that line. Make it straight. There we go. Here, again, the same deal. If this is 101 degrees, the side opposite of it is 68. If I say this is beta, then this is 96. Now, if you could tell something's wrong from the beginning, that's a good catch, because if this is 101, that's the biggest angle, there's no way this could work. There's no way you could have the side opposite of the biggest angle being smaller than another. That's like saying the hypotenuse is smaller than one of the sides of a right triangle. That's not possible. And if you don't see that, let's make sure we go ahead and proceed. If you didn't see that, you're going to say the sine of 101 degrees divided by 68 equal the sine of c over 96. That means the sine of c equals 96, the sine of 101 degrees divided by 68, which is 1.38. And when we get to the next section, you're going to figure out why a sine, the next chapter, a sine can be bigger than 1, assuming you don't see that. If I plug this in my calculator and I take the inverse sine, I'll get an error message. That means no such triangle is possible. And the moment we've all been waiting for, if I look at the third case, if I look at this case, you say, okay, well, let's see. Let's draw a possible triangle. Well, a possible triangle would look like this. I could say I have a B. Let's say this is B. And let's say that's 39 degrees. That's given. This is 40. Okay. And let's say this is A. That means this is 48. And this is C. And this is side C. Well, let's see how this works. If I go for finding, well, the first things first, I can only use the sine of 39 degrees to 40 to equal the sine of A to 48, which means the sine of A equals 48 the sine of 39 degrees divided by 40, which is sine of 39 divided by 40. I'm getting this to be a 0.755. Again, I'm using the answer in my calculator, so I'm not rounding. And A would be one of two things. If I take the inverse sine of my answer, it's either 49 points, so I'm going to say 49 degrees, or in quadrant 1, or in quadrant 2, minus 180. 131 degrees. Well, let's see. If I go by strictly 49, if I say, you know what, this is 49 degrees, that's fine, we could do that. What does that mean? That means this angle right here is 180 minus 49 minus 39 degrees. Angle C would be 180 minus 49 minus 39. That would be 92 degrees. Okay. And then can't I say sine of 39 degrees to 40 equals sine of 92 degrees to C, and C would be 40 times the sine of 92 degrees divided by the sine of 39 degrees, and C would be 63.5. And you notice everything makes sense. The biggest angle is opposite of the biggest side, and the smallest is opposite of the smallest side. So this all works based on what we marked in yellow. Got it. But what if I decided to take the 131? I could redraw this triangle slightly different. I could say, look, I might have drawn it wrong. if I make a 131 degrees, so if I redraw this, I say, look, let this be A, let this be B, let this be C. I know this is 40, that's given, and I know this is 48, that's given. This was 39 degrees, I found it. But now I'm using the 131 degrees. Well, in that case, I could figure out what C is. That's 180 minus 131 minus 39. And I could say C is 10 degrees. Okay, that's doable. And I could say the sine of 39 degrees to 40 equal the sine of 10 degrees to side C. And C would equal 40, the sine of 10 degrees divided by the sine of 40. And I could get an answer out of that as well. And if I take 40 times the sine of 10 degrees divided by the sine of 40, I can get this to be 10.8. And what do you know? It worked here as well. So this is the case when you have two triangles. Every time you use the law of sine to find the angle, you should aim for the smallest angle. This way, you don't fall into this what's known as the ambiguous case. And you'll see I do that as well every time I do this. Suppose I want to solve this triangle. Solve the triangle. Find everything that's missing. Well, I glance at this, say, okay, well, how am I going to do this? Well, if I look at the whole triangle first, all of it, can't you say the sine of 35 degrees to 31, call this A. That would be the sine of A to 23. And wouldn't you say the sine of A equals 23 the sine of 35 degrees divided by 31, which is 23 the sine of 35 divided by 31. That is 0.43 about. And if I use my answer and take the inverse sine of my answer, I'll get A to be 25.2 degrees. Now, how come I'm not saying or? Isn't this side bigger than this side? That means this angle has to be smaller than 35. That's how you play it safe. That would be the right thing to do. And now, if I look at this triangle, wouldn't you say the sine of 35 degrees to 18 equals the sine, call this B, to 23, and the same argument, sine of B equals 23 the sine of 35 degrees divided by the sine divided by 18. So what would that be? 23 the sine of 35 divided by 18. That is really 0.73. And then you would say beta equals what? Now let me see. You know what? This is 154.8 degrees, but we can't have that here. If I take the inverse sine of my answer, I'll get my angle to be 47.1 degrees or 132.7 degrees. But again, 23 is bigger than 18. That can be the case. I know this angle right here is 47.1 degrees, right? And hey, guess what? Isn't that a straight line? Isn't that 132.7 degrees? Now that I know this, can't I say this is 35 and this is 25.2? Isn't that 180 minus 35 degrees minus 25.2 degrees, which is 119.8 degrees? And now I could say the sine of 119.8 degrees, not really. Oh yeah, on the right side, divided by, and call this side C. I could find each piece by using each of those. I could find the whole side, right? We need the whole side. That equals, and can't I say the sine of 35 degrees divided by 31? And I could plug this in my calculator. 31, the sine of 119.8 degrees divided by sine of 35 degrees. And I can get this side C to be 46.9. And that pretty much takes care of the whole triangle. It's a heck of a problem, but it's worth doing, really. It's a good exercise for what's to come. Let's get 3 more problems out of the way. A plane is flying over a straight highway. A plane is flying over a straight highway. Let's say the plane is right there. Two cars 11 miles apart are on the east side. Okay, I didn't see that. I forgot what I wrote. So here. Two cars are on the east side. Both of them. 11 miles apart. This distance is 11 miles. And the angle of elevation I'm going to erase that a bit just to make it. There. So this is the plane. These are the cars 11 miles apart. Angle of elevation is 65. This must be the 65. And 73. As you get closer, you have to look higher. How far are each car from the plane, and how high is the plane? Alright, how am I going to do this? This is what I know. This is... Okay, it didn't register. I know that this is 11 miles. Okay, how does that work? Well, if this is 73 degrees, can't I figure out what this is? Isn't that a straight line? Wouldn't that be 180 minus 73 degrees? Right? That's 107 degrees. Okay, and now what? Let me see if I needed that one. Yeah, I do. I need the hypotenuse, sure. And what would that be right there? Wouldn't this be 180 minus 107 minus 65? (180 minus 107 minus 65), and that would be 8 degrees. And now can't I say the sine of 8 degrees to 11 equal the sine of 65 degrees to, call it x, this being x. Well, isn't x 11 the sine of 65 degrees divided by the sine of 8 degrees? And I could get that x, which is the hypotenuse, and that's a big deal. 11 the sine of 65 divided by the sine of 8. I'm getting that to be 71.6. 71.6. So this is what I have, the first question, right? Call this A, call this B, I got X. If I call this second car Y distance away, wouldn't you say the sine of 8 degrees to 11 equal the sine of 107 degrees to Y? And Y would equal 11 the sine of 107 degrees divided by the sine of 8. And Y would be 11 the sine of 107 divided by the sine of 8. I'll get that to be 75.6. There. I got the first question answered. How far are each car? One of them is 71.6 miles and the second one is 75.6 miles. Now what? Now they want to know how high is the plane. Well, if I look at this plane, let me think really quick. If I look at this triangle, think about it. I have an angle. I want the opposite and I have the hypotenuse. Doesn't the sine of 73 degrees equals the opposite over the hypotenuse? If you cross multiply, so I don't need the law of sine if it's a right triangle. And if you use the law of sine, you're okay. You're going to say the sine of 90, which is 1, which is this part. That's no big deal. So what would be the answer? 71.6 times the sine of 53 degrees, and I'm getting the height of the plane is 57.2 miles. If I look at example 6, it says a tree leans 6 degrees from the vertical. If this is the vertical, the tree leans 6 degrees from the vertical. A woman stands 35 feet from the base of the plane of the tree, well, which side, this side or this side, with the tree leaning toward her. What does that mean? That means the woman is standing on this side of the plane. This right here, so this is a right, but it's off by 6 degrees. This is, let me use that green. This is 35 feet. That's where the woman is. And that's the tree. And then it says, she measures the angle of elevation. We know what that is. To be 17.4 degrees. How tall is the tree? How am I going to do this? Well, if this is 6 degrees, can't I figure out what this angle is? Right? If it was standing up, that's 90 degrees. Wouldn't you say this is 90 degrees minus 6 degrees? This is 84 degrees. And if this is 84 degrees, then this is 180 minus 84 degrees minus 17.4 degrees. And that would be 76.6 degrees. So pretty much this is what I'm looking at. If you'd draw that and get out of the actual word problem, you'll notice you did those already. We did those in the very beginning of this section. This is 76.6 degrees, and this is 17.4 degrees. This is 35 feet, and I'm looking for this. Well, isn't it this easy? I could say the sine of 76.6 degrees to 35 equal the height of the tree divided by the sine of 17.4 degrees, and x will equal, I think I messed up on those. The order is backwards, right? I got excited. I apologize. That happens a lot when I teach. So x equals 35 the sine of 17.4 degrees divided by the sine of 76.6 degrees, and that would be the feet, the height in feet. And if I get my calculator, 35 the sine of 17.4 divided by the sine of 76.6, and it is 10.8 feet. That's how that actual tree is. One more problem to go. Okay, assume I'm giving you this diagram. In the book they have diagrams which I will copy and change the numbers, so it's the same thing. It says a flag post, there's the flag post, is located on top of a hill, there's it is. The angle of incline of the hill is 51 degrees. A guy wire right there attached to the top of the post and a point and to the ground somewhere on the hill, 85 feet down the hill from the base of the actual tower. This is the base. And if the guy wire makes a 13 degree with the actual hill, what's x? So to do this, I would really take this line and move it up there. This is parallel, which means what? This is 51 degrees. This is 90 degrees. That means if I eliminate that 85, I know what it is. This is 51, oh look at the degrees, how does that work? This is 51 degrees, this is 90. I could figure out what this is. That's 90 minus 41, 90 minus 51, which is 39 degrees. And I could figure out what this is because that's a straight line. That's 180 minus 39, which is 141 degrees. If I redraw this really quick, I have this flag post. Pretty much what I have, 13 degrees, 141 degrees. This is 85 feet. This is what I'm looking for. Well, automatically I could figure out what this angle is. 180 minus 141 minus 13. That is 26 degrees. And how hard is this problem? It's as challenging as you reading the graph. The sine of 141 degrees to x equal the sine of 26 degrees to 85. And there it is. X equal 85 the sine of 141 degrees divided by the sine of 26 degrees, and that would be in feet. And if I get my calculator out, 85 times the sine of 141, make sure you have a scientific calculator and make sure you know how to use it. And on the exam, make sure you show me everything that I'm showing you right now. And that would be it. And that concludes this section.